The wavefronts. A wavefront is an imaginary surface that we draw to represent the vibrating part of a wave. The crests of waves can be thought of as wavefronts. A vibrating source produces a succession of wavefronts, all of the same shape. If you throw a stone into a pond, circular waves are produced. The circular lines are the wavefronts. If you dip a ruler in a tank of water, you will generate straight ripples. The straight lines are the wavefronts. In our study, it's helpful to define another way of describing these waves and their propagation through the medium. Let's introduce the concept of a ray to describe the direction of propagation of these waves in the medium. A ray is an imaginary line along the direction of propagation of the wave that is perpendicular to the wavefront. These rays will be straight lines. A line drawn at right angles to a wavefront which shows its direction of travel is called a ray. Straight wavefronts and circular wavefronts, their corresponding rays, are shown in figure below. Pay attention. The reflection of waves. Reflection is the change in direction of a wavefront at an interface between two different media, so that the wavefront returns into the medium from which it originates. Pay attention. The perpendicular to the strip at the point where the incident ray strikes is called the normal. The angle of incidence is the angle between the incident ray and the normal. The angle of reflection is the angle between the reflected ray and the normal. The angle of incidence and the angle of reflection are always equal. The refraction of waves. Refraction of waves involves a change in the direction of waves as they pass from one medium to another. The density of a material affects the speed that a wave will be transmitted through it. In general, the denser the medium, the more slowly waves travels through it. Imagine what happens to one wavefront as it enters the water. The wavefront strikes the interface with a more dense medium, and there is some reflection and some transmission. Part of a wavefront enters the water and slows down, while the rest of the wavefront stays in the air at its original speed. As the speed into the water is less, the wavelength of this part is less as well. The frequency stays the same because it depends on the source only. The wavefront in the air tries to speed ahead the wavefront in the water, but they still have to join smoothly at the boundary. This causes the whole wavefront to bend as demonstrated in the figure. The angle of incidence and the angle of refraction are different. The diffraction of waves. The spreading of waves at the edges of obstacles or around an object is called diffraction. Since there is no change in speed of the waves, the wavelength remains the same after diffraction. Diffraction is strongest when the wavelength is similar to the size of the gap or object. Pay attention. Now it is your turn.